Okay, here's another example of a system of equations, but this time my two equations are not in y-intercept form. So we need to rearrange these equations, use our skills that we know how to use to solve two-step equations to get the y all by itself and get it into y equals mx plus b form. All right, well, let's work on the first equation first. I have negative 5x plus 2y equals 6. So I'm going to have to move my x over to the right side and then get y by itself. So let's start by adding 5x to each side. That will cancel out 5x over here, and then I'll be left with 2y equals, now I have a positive 5x on the right side, and I have a positive 6. We're almost there. We still need to get this y by itself. So to do that, I'm going to have to divide everything by 2 on both sides. So on the left side, my 2's cancel out, and I'm left with y equals. And now on the right side, I have 5 over 2x plus, and then 6 divided by 2 is 3. Now I have my equation in slope-intercept form. Y equals 5 half x plus 3. And I can graph this. So let's use our y-intercept, which is positive 3, to plot our first point on the graph. So positive 3 on the y-axis. Y-intercept is always on the y-axis. And then from here, my slope tells me I need to go up 5 over 2. So for our next point from our y-intercept, let's go up 5, 1, 2, 3, 4, 5, over 2. Right, now if I go up 5 over 2 again, I'm going to be off my graph, but it's okay. I can carefully use a straight edge to go through these 2 points to draw a line. Okay, need to be pretty precise about it, and I need to go long enough so that I have room to intersect with the other equation. Lightsabers in the background. Sorry for that. Okay, my second equation now, negative 2x plus 2y equals negative 2. Let's move this one and rearrange it to be in slope-intercept form. So to move this x over to the other side, I'm going to need to just add x to both sides. So add x over here, add x over here, and then this goes away, and I have 2y equals, now on the right side I have a positive x, and I still have a minus 2. Almost there. We still need to get this y by itself, so let's divide everything by 2. So on the left, my 2's cancel, and I have y equals, and then here I have x over 2, but we know that there's an invisible 1 here, right? So I really have 1x over 2, or 1 half x, minus, and then 2 divided by 2 is 1. All right, now I have my second equation in slope-intercept form. And it's ready to graph. Let's start with our y-intercept, which is negative 1. I'm going to graph it on the same graph as my other equation. So my y-intercept is negative 1 this time. Let's go to negative 1 on the y-axis. And then my slope tells me I'm going to go up 1 over 2. So let's plot a couple points that way. Going back to my y-intercept, I'm going to go up 1 over 2. Up 1 over 2. So now that I have a few points plotted, let's carefully use our straight edge and draw a line through that set of points. All right, now I see that I have a point of intersection down here in the third quadrant. And what point is this? What ordered pair is this? Well, I see that it is negative 2, negative 2. So my lines intersect at the point negative 2, negative 2. This is the solution to my equation. Now I should be able to take this x and this y and plug them back into my original equations over here. Either one or both, plugging negative 2 and negative 2 into these equations should work and make them true. And so now I have solved my system by graphing.